Hey guys, welcome to another example video. In this video I want to show you an example of combining functions together. So I've picked out here a couple of examples, but know that you can combine functions by adding, subtracting, multiplying, and, like shown here, dividing. So the way that we combine functions in these ways is pretty straightforward and just like you would expect it to be. This notation here is function notation telling us to add f and g together and then identifying that the input variable is x. The name of the function is f plus g, and this name is telling us what operation to perform. And this right here is always just telling us what the input variable is. Right. So in order to find f plus g of x, all I have to do is take the function f of x and add it to g of x. So this is equal to f of x plus g of x. So again, function name, input variable, function name, input variable. And since f and g are defined this way, all I have to do is substitute those in. So the square root of 2x minus 1 plus 1 divided by x minus 3. Now I chose these two functions on purpose. Now what you want to do is simplify this as much as you possibly can. We don't have a like radical we can add. We don't have like denominators. This is as far as simplification is going to go. We could combine this into a single fraction. There'd be nothing wrong with that. But I'm going to leave it like this. What we also need to find is the domain of this function. Now, to find the domain of this sum, difference, or product of two functions, what you're going to do is find the domain of each of these functions separately and then find the intersection. So in order to find the domain of f plus g of x, what I need to do is find the domain of f, domain of g, and then intersect the two. So if I look back up here at how f of x is defined, f is a radical function. It's the square root of a quantity, and we know that we're not allowed to take even roots of negative numbers. So I'm going to find the domain of f right down here. So again, f of x is the square root of 2x minus 1. And I know I'm not allowed to take even roots of negative values, which means 2x minus 1 is not allowed to be negative, which means it must be greater than or equal to 0. So all I have to do is solve this inequality. Which tells me input values have to be 1/2 or larger. And I'm actually going to write this in interval notation because it's going to make this intersection a little bit easier. So greater than or equal to 1/2, so bracket 1/2 to infinity. Okay, and then I need to find the domain of g, and I'll do that here. So let me go back up and grab the g of x function here, 1 divided by x minus 3. And I need to find the domain of this function. So this one doesn't have a radical, but it does have division, and I know that I'm not allowed to divide by 0, which means x minus 3 cannot be 0. So I just solve this equation, which tells me every input is allowed except 3. If I plug in 3, it will cause me to divide by 0, which is an absolute no-no. So if I write this in interval notation, that's all real numbers except 3. So I've got parentheses here to exclude the number 3, but everything else is allowed. So what I need to do is intersect these two sets to tell me the domain of their combination, right? So maybe I'll draw these on number lines to help me with that intersection. So we've got, let's say 0 is here, we've got a half and positive 3. And so the domain of f is 1/2 and larger. The domain of g is everything except 3. And so what I need is the intersection of these two. I'll just go over this with my pen in case that highlighter is hard to see. Okay, so I need to intersect these two sets. So it looks like the intersection starts here at 1/2 and continues until the number 3. The number 3 is not included. And then both of these continue on from there. So the domain of this combination right here is going to be this intersection here. So that is 1/2 to 3, and then 3 to positive infinity. So here's the combination, and here's its domain. Now, when it comes to dividing these two functions, almost everything is exactly the same. So this just says take f of x and divide it by g of x. So f is square root of 2x minus 1. G of x is 1 over x minus 3. We need to simplify this. I have a fraction inside of a fraction, so I will multiply by the reciprocal of the denominator, which gets me this lovely function. So this is the combination, and the domain is almost exactly this. Okay? The only thing we have to double check is that g of x is not allowed to be 0. Okay? So remember from reading in your textbook, this is the domain of f plus g, this is the domain of f minus g, this is the domain of f times g, but when you're looking for f divided by g, there's one extra step that you have to do, and we have to make sure that g of x itself isn't equal to 0. So I'm going to do that down on the bottom of my page since I am running out of room. So g of x is not allowed to be 0. So g of x is 1 over x minus 3. It's not allowed to be 0. I have to make sure that that's not going to happen. So if I try to solve this equation, maybe by, multiplying both sides by x minus 3, I get this cancels. 1 is not allowed to be equal to 0, which will never happen. Okay? So because this will never happen, I don't have to exclude anything else from this domain. However, if there is an x value that will make g of x equal to 0, all I have to do is take that out of this intersection. Cool. So this is the domain of this function as well as this function.